Hi guys, welcome to this 7th episode of the OpenHT Firmware development series on the M17 TV. So, stream starting a bit later than usual today, but anyway, we are getting close to being able to transmit things with our proof of concept board, and so yeah. Hi Hervé, hi Wojciech. Yeah, Hervé, you are not the first, sorry. You're still are not on the M17 Discord, so there is no way you will be first. Anyway, so we are getting closer and closer every day to being able to transmit something with the development board, the proof of concept board with the Nucleo board as the microcontroller and screen. So lots of work have been done since the last time we talked. Mainly, we are now able to discuss, let's say, with the image that Wojciech made for us on Radiant, which is damn slow software, let's say. So yeah, we know how to discuss with it and talk. We have tested a bit the SPI communication bus, and we did pick a communication speed which will be ideal, let's say. So we are not so slow that we might have problems down the line, but we are not so fast that the FPGA might not have the time to write to the line. So this has been done in the past days. We also we also tested a few things, and I started lately to write the registers, the configuration registers of the transceiver in this big fat header file. So 300 lines of goodness. Those are only the registers that we might be interested in. They are, I think it's a bit less than half the registers that are available on the device, but as we only use it using the IQ interface and not the baseband module, it eases up the process a bit. So yeah, I tried a few hours ago to write a snippet of code that would allow me to read the version number and parts number of the transceiver using the SPI bus, and I was not able to make it work, but I realized my mistake just a few minutes ago. So what I propose to you now is that we have a look at this, fix this error, and then yeah, once this error is fixed, we will be able, hopefully, to read and write registers from the transceiver. So the problem is that, so I have written, in the taskradio.c file. So right here, I have flag which is triggered whenever I have to initialize the transceiver. So I first put it out of reset, then I write in a register to save, because we first initialize the transceiver in order to have clock output for the FPGA. Then we start the FPGA. Problem is that between the time I put the transceiver out of reset and the time that the FPGA is ready to send samples, I have to configure it and so on. And during that time, the LVDS pairs connected to the radio, to the transceiver, are not driven by anything. So first thing I have to do is put the transceiver out of reset, and then I have to write to the IQ, IFC1, whatever register, and tell it that the IQ pairs are not driven yet. So that's what I do, and then I try to read the part number and version number. However, so it's an SPI bus, so that means that the first thing I have to do whenever I read or write on the bus is put the chip select line low. I just realized that, so if you remember from a few episodes ago, the problem that we had was that there was kind of a conflict between the SPI chip select for the transceiver and the I2S for the sound and to sample the microphone. So what I had to do was I had to configure the device in I2S, and so that means that this is set by default in I2S mode. So if you have a look here, you see that it's I2S3_WS, which is word select for the I2S, but we don't use it. However, I haven't reconfigured it anywhere as a GPIO. So let's do that right away. I just have to check where I initialize the I2S to be sure that I don't mess with it. And it would be in the task microphone, so that would be in this file. And yeah, right here, that's where I configure the I2S. And I guess it would be in I2S init, I2S MSP init, and then I have to find the correct one. Right here. So we have pin B3, D6. Yes, so I think, yeah, it's in the function task, in the file task microphone, so this is not generated by CubeMX. So that also means that I already removed the initialization for the PA15 pin, which is the pin that we want to use. So that means that I can go in the GPIO init function, which is here, and I can initialize PA15 however I see fit. So GPIO init struct dot pin equals XCVR NSS pin, so which will be 15. Mode is gonna be GPIO mode output push-pull, so it can drive it high and low whenever I ask it. Hi Andy, how are you? So GPIO init struct dot pull. We don't want any pull. Init struct dot speed. Speed low. It's good enough for us. Also, what I would like to check is how do I make sure that it's not initialized for a function, but I guess, yeah, as it is the GPIO initialization function, there it won't be, yeah, okay, so I don't need to set it. Okay, perfect. And so right after that, I have to call function HAL GPIO init, and it will be GPIO A and GPIO init struct. Okay, so like this, the pin PA15 should be configured as an output push-pull, no pull-up, no pull-down, and the drive is just enough for it to have a low speed, which is still a few megahertz, so way more than what we really need, right? Okay, so I have to recompile. Perfect, and now let's program it, and quickly we'll be able to see what are the data read from the transceiver. Let me just check what is supposed to be read from those registers so that I'm sure that we read those registers correctly. Okay, so we should read 34 or 36, it seems. and the version number. Okay, we should read 1 or 3. Great. Okay, so it's done downloading the code. Shell is here and ready. So let's power on the board and see what goes on. And okay, so part number read is correct. Version number read is 0. That's unexpected. We shouldn't read 0. But at least now I know that I'm able to talk with the transceiver, so it's great. Also, yeah, I'm using a custom FPGA image. It's the one that I used for to test the reading and check the timings and so on. So if you want more details, don't hesitate to join us on the Discord. It's where the biggest part of the development is done, and the discussions and so on. And you will see all the exclusive stuff, let's say, so all the pictures and screenshots that we do from our instruments and so on. Okay, anyway, why am I reading 0 from the version number? Just let me check that there is no error anywhere in the code. Okay, so I'm yeah, that's the same function used for both. That's strange. Okay. Okay, what if I power it down and up again? Oh, both are reading 0. Wait. Yeah, it's not very consistent. So here is 34 and 0. Here is 0 and 3. 0 and 0. 34 and 0. Okay, so quickly check what's the max speed for the SPI interface, maybe. Oh, Steve, you're not the first, sorry. Next time you will. Okay, no audio, okay. I hate that, Wojciech, when you just say no audio, because previously when somebody was saying no audio, that meant that nobody was hearing me because my mic was dying. So I always panic a little bit when you say that. And as you have no audio, you don't listen at what I'm saying, but anyway, I said it. Okay, SPI timing characteristics. Okay, we have up to 25 megahertz, so great. We are below that, we are 5.6 megahertz. So yeah, okay. He has audio. He's just, yeah, he's indeed just muting me because of the wife, I guess. Okay. Okay, what would that be? Let me just check quickly. Yeah, okay, it should be slower than that. How was it done in these functions? Yeah, okay, so it was yeah, just transmitting yeah, 3 bytes timeout. Oh, that's a very short timeout. One millisecond, okay. Okay. I don't really know what could be improved to make it more reliable. Okay, let me just disable part of the logs so that we are not flooded by uninteresting content. Yeah, so it seems that okay, well, don't worry too much about the rest of the... Or maybe... Hey, wait a minute. Maybe we don't have a delay long enough between the slave select and the data transfer. Interesting. Okay, let's reset the board. Okay, so still working. Okay. So that's an interesting situation. If we disable the log, it doesn't work. Okay, I will tackle that later on. I guess a pair of delays should be enough for each transaction. We will do that. Anyway, yeah, we also have a quite of a weird situation with the RTOS. Which is not working as expected. So this one in particular, yeah, I think this one, it sometimes appears without any explanations. I don't really know. Because the FPGA revision reads correctly. Ah, not all the time. Okay, and if I re-enable the log, yeah, then it works. Yeah, it's probably just a matter of delay between all the pins and so on. Okay, anyway, we can leave the logs enabled for now. That's not a big problem. Okay, however, what I would like to know is why I can't read reliably the part number and the version number. So what about I insert a small delay between those, even though I have already a printf between those which acts as a hard delay. Let's try with that one, or maybe no, I don't know. Yeah, let's retry like this. Otherwise, the last resort is using the scope to probe the signals. Hmm. 0, 0, and 0, 3. Oh, this time we read both correctly. Okay. And this time we did not. Okay, let's quickly check in debug. And I'm already gonna solder a small jumper wire on the slave select line. Okay, so slave select line, I can now probe it. Let's just prepare our thing. So I'm just getting all the probes ready to be able to decode the signal. So being off stream for minutes, and then I come back to you. Okay. Getting everything ready. Okay. Oh, there is no music, you're right. Wojciech, while you have the sound enabled, I will need to know what to do with the FPGA if I want to send a continuous wave. I think the FPGA will send the sound, will send the signal not quite at the tuned frequency, but with a slight offset, if I remember correctly. So if you can just write me a few lines to tell me what to do, that would be much appreciated. And setting the sound. I have saved the link this time, so I will start it in a few seconds. Okay, like this. All right. Let me just see how the scope is configured. Okay, so if I click now, wait, oh yeah, okay. Right here, and if I click here, I should sample the transfer. Okay. It seems I misconfigured my channel, so let's restart and change the music. I think I already had that one and I already didn't like it. Let's move on. Okay. Okay, so it seems that the oscilloscope catch both transfers and both are reading correctly here. So yeah, maybe there is a problem with the way we store data. Interesting. So if I have a look, okay, no, maybe I will open it in the web browser so you can have a look with me. Okay, so here is the signal. We just will have to zoom. Yeah, so everything is done in less than 5 milliseconds, which is reasonable. Let's zoom now. Okay, let me just use the buttons, it's gonna be faster. Okay, so what we see here is that it seems that everything is set at the correct timing. So the pink line is the one that the transceiver writes to, and we can see that it writes to it whenever the clock is on a falling edge. So that means that, yeah, we are reading the data correctly, and there is no way that the error that we have comes from here. So if we have a look that way, that's the moment I... Oh. Oh. Using the computer is not as easy as using the buttons. Okay, so right here is the part where I send the commands, and right there is the part where I read. So the left 2 bytes, the 2 bytes, this one and the one left to it, which we don't see, is where I write the address of the register that I try to write to, or read, sorry. And this is the value returned by the transceiver. If I move to the right a bit more, maybe I can unzoom a bit to move faster. Oh, it's gonna start at 4 milliseconds, so... Okay, and right here is the second transfer, where I read the version number. And we can see that everything is done correctly. Hi Jay, how are you? So you have the board too now, I saw. Okay, so this is all good. Let's maybe try a second. I would like to see if I can do an acquisition where it reads 0 for one of those. So let's go here, reset, run the code. Yeah, it's always reading them correctly. Okay, let's try something. So inserting delays, so just pay attention that when you are on a free RTOS and you ask it to wait for 1 millisecond, it's gonna wait for until the next millisecond. So it's almost always gonna be between 0 and 1 millisecond. But in our case, it should be long enough. We just need like a couple of nanoseconds, so that's way more than we need. And let's try to see what we can catch. Okay. Ah, that's no good. It's reading something, but it's not reading the correct value. That I don't really like. Why is it? Oh, maybe... Okay, let me just check on the scope. Aha. That's interesting. So that we don't really care about, but 0B82, so that's when I write the settings of the IQ interface. But what is worrying is this one, where I read 0 and I have a 10. Maybe there is something I'm not respecting in the configuration of the FPGA, of the transceiver. So maybe I should wait for a few milliseconds after I put it out of reset. So let's try that maybe. So that would be here. And here, put it out of reset. OS delay, let's wait 5 milliseconds maybe, and retry. In the meantime, we're gonna have a look. Power on reset. Okay. It seems that, yeah, maybe waiting a little bit would be beneficial. So let's try. Aha! I don't know if it's the fix that we were looking for, but it read everything correctly this time. Let's power it off. Start an acquisition and restart them. I see something I don't like. It's read a 1. Ah, again. Yes, I do assert the right CS line. I already checked that. If I did not, it would read 0. Okay, what I would like to do too is set this one to 0 so that I don't read wrong data. Yes, I do reset the transceiver using the reset line. So let's have a look quickly at this transmission. Aha. Aha. What's going on? Okay, so it seems that we can see the problem right here. For some unknown reason, the MISO line is not driven to 3 volts. And that may be why we don't read the correct data. And that I have no idea why. That's very, very strange. Yeah, I guess I won't be able to measure the voltage at that cursor because it's always annoying doing that for some reason. But yeah, we can clearly see that it's a bit below 2. Hi Mark. Yeah, it seems that I found the issue, but the problem is that we should, hopefully, we should try to find the solution. That's what I don't really like. What would make it write less than 3 volts? That's a very strange issue. So let's see in the datasheet. Okay, errata. What do you mean by what does it fan out to? Okay, I see nothing related to it. Oh, yes, indeed, you're right. That you are very right, Mark. The FPGA is connected to it. But the FPGA That would be very strange. But indeed, the FPGA is connected to it, and maybe we could have some weird issue with it. It shouldn't, because whenever we power it on, so we arrive. Sorry, looking for the function here. So this is where I manage everything being powered on and off. So when it's powered on, program and pin is set high. And it's when you create a falling edge that the FPGA kind of wakes up. However, yeah, no, so, oh, no, okay. FPGA slave select is set high, as is the transceiver slave select. So okay, so our other option would be to write, so we will write this here because it tells the device to ignore the LVDS pairs, and it seems that to write to it we don't have any problem. So I am doing everything for the FPGA, blah blah blah, reading the FPGA revision, and here I'm gonna try reading from the FPGA, from the transceiver, the part number and version number. I release the FPGA chip, and in here I select the transceiver chip. Okay, let's try that and see if maybe we have more success. Ah, yes. Hi Bastien, how are you? Okay, programming is done. Doesn't seem better. Seems worse actually. Don't really like that. So if you have a look at the SPI lines, the one we are interested in is the master in slave out, this one. And if we go to the root page, master out slave in here, and master out slave in. So if we go here, master out slave in, directly connected, Mozzie pin. All right. And if I go here, oh, come on. Master or slave in. Yeah, so it seems that it's those are the FPGA and the transceiver are directly connected to each other, and they are connected to the master or slave in, yeah, via a 100 ohm resistor to the microcontroller. Okay, that's really a weird issue. Ah, the exams, yeah. I know the feeling. Let's try okay, let's first make sure that we don't have any pull-ups or pull-down. Aha! Aha! Okay, ladies and gentlemen, we can all clap once for Wojciech. Yeah, kidding. Of course, it's not easy imagining everything out of the system you are designing. So, of course, I don't blame you if that was the doubt. But yeah, if it's not what the code is doing, then we might have our culprit. However, I'm still tickled by the fact that we have half the voltage even when the FPGA is not programmed yet. So that's not supposed to be the case. Okay, okay, it's 11:30 p.m. I really wanted to be able to try having any kind of a mission today, but realistically I don't think I will be able to, because if I have to modify the VHDL code I would have to understand it and modify it, which is not a realistic target given my state of fatigue. So let's try to pretend that everything is working alright. And so okay, let me just think for a second. What we have to do is imagine that it's working, and what would be the next step. So now that we are able to use the transceiver, we can communicate with it, everything seems to be working. The next step is configuring it. So we will go, I propose that we go through the datasheet to see what are the main registers that we are interested in, and see what are the values that we have to write in those. So I already had a look at this datasheet in the past, so may you have done so in the past. But previously when I had a look at it, I was mainly interested in what I have to do for the hardware design, not for what I have to do when talking with it, which is what I'm doing now. So I will go through the datasheet again and we will see, okay, what do we have to write in which register to have it do a continuous wave at a set frequency, for example. Cheers. So I don't know where you are from, you who are listening, but still pretty hot today in Belgium, 11:30 p.m. and still decently hot. So stay hydrated, guys. Okay, let me have a look. No worries, Wojciech. I made way worse mistakes, except that I shut down the stream before discovering them, so no worries. Oklahoma City, 30 degrees C. Yeah, kind of the same vibe, except that it's 11 p.m. here. Maybe it's not 30 degrees right now, but still decently hot with all the machines running around. Air coming from the cabinets at 15 degrees C. Oh, SR5MS, is it the M17 relay from in Poland, I guess? Yeah, it's definitely lower than the 29,500 degrees Celsius that it was at previously. Which is decent temperature for winter, maybe. Keeps you warm. Okay, enough talking, let's get back to coding. So, I don't know if I described it to you already. So the way I manage the tasks in my threads is that I have a flag that I wait for here, and then every time I have one flag set, I process it. So I have several flags that already exist. We have to send sample, to fetch the IQ samples, which was something that Wojciech asked me to do, which I still haven't done, but slowly, bit by bit, we are getting there. Then uploading the bin, which is the bit stream. I should maybe rework some words to stay more consistent But anyway, so upload it, we send it to the FPGA, download, we read it from the microSD and send it to the NOR flash. FPGA resets, which isn't implemented yet, I think. Erase storage, which basically erases the EEPROM and erases the binary storage. Then init and changed, so that is used to detect whenever we are powering up and on and off the boards. But still a few quirks to fix, I think, on that one. And transceiver init. So whenever I start the FPGA, the board, I detect that it's powered on, I set a few GPIOs, and then I tell it to initialize the transceiver. Then once it's done, I tell it to upload the binary bit stream to the FPGA, and then we are done. Then what I'm gonna add now is, after uploading the bit stream to the FPGA, I want to configure the transceiver. So configure it with the correct frequency, correct bandwidth, correct sampling rate, correct everything. So that's where I could be making mistakes, because that part was handled by Wojciech, because he's the one who managed the talking between the FPGA and the transceiver. So the way it works, if I have a look back at the schematic, is that we have a lot of LVDS pairs. So LVDS stands for low voltage differential signaling. Basically you have two wires, one's going up, the other is going down. So you have a symmetric signal. And that makes it more immune to common mode noises, because if I move all lines at the same time, I still keep the same voltage difference between those. And so that's how we are able to make strongly immune signals, but also those are low voltage, so the difference in millivolts between the two lines is a few hundred of millivolts, and the fact that it's low makes it so if you want, you can see the pins of so for a second we are going to imagine that the pins of a microcontroller or an FPGA are like capacitors. And the way capacitors work is that when you put a voltage across them, you have to load them or unload them. The higher the voltage, the more time it takes to load it and unload it, because it has to charge up to a higher voltage, of course. So the lower voltage you are, the less charges you have to put in and out of those capacitors, and the faster it is. So low voltage differential signaling, we are differential to stay immune and low voltage to be fast. Anyway, those sends the I and Q data from the FPGA to the transceiver, but those are supposed to be at a certain voltage, a certain speed, and this was handled by Wojciech and is hard-coded in FPGA, because it wouldn't make any sense to be able to change it on our side. It doesn't make any sense. So it is hard-coded in the FPGA. So I'm gonna have a look, of course, at these 8086 RF215 functions. Oh, and we already have the set frequency, so that's great. Then config common, and yeah, we will have to modify that one to set it to the IQ mode for both transceivers. Sorry. Okay, I guess those are used to... Oh yeah, okay. PPM, oh, we can have a change in PPM, okay. Automatic gain control target. So this is to set it to receive mode, transceiver, transmit mode in 900 in sub gigahertz and in 2.4 gigahertz. So basically what we will have to do is reuse those, and yeah, okay. Okay, first thing we are gonna do is add a new flag, which is gonna be called define transceiver config. So the way the flags work is that each flag is one bit. So in a word of 32 bits, you have 32 different flags. So we use a 1, which is a single bit that we shift around the word to choose which flag we are using. I have to add this one to the all flags defined, because so this is used when we wait for something to happen. We just say wait for anything, which is radio all flags here. Okay, so the way I place those in the main loop is not at random. I try to put them from the most common to the least common. Most common will be send samples. That's what we are gonna be doing a lot. Actually, more common than that would be receive samples, because will be receiving more than we will be transmitting. So we would have to add a flag FPGA receive samples right before this one, then send samples, then fetch IQ, because that would be a task done very frequently when we will be doing it, even though I don't know when we are gonna use it. Then init and changed, which is when we power the board on and off, but we won't be doing that like several times a second, so like it happens at the beginning and at the end. So I'm just gonna be before that one, so let's do this like that. And flag and xcvr config. First thing we are gonna do is clear the flag. Thread flag clear. Transceiver config. Because whenever we wait for a flag here, we don't clear it, because otherwise we may have a state in which we have to stay several iterations, for example, I don't know. So each state decides when it clears its flag. In this case, we want to clear it immediately. Okay. Transceiver config. We are gonna have to access. Okay. I think I have to merge code that Jae wrote. Let's have a look. So CPS M17 info. Yeah, okay, this is code from OpenRTX that we copied to reuse it. Okay, so he added a new emulated EEPROM for the radio settings. So we are gonna split the settings in user settings and radio settings, which are gonna be two different things. In the radio settings, you have the RX and TX frequency, AGC target, okay, output power, great. The mode that we are gonna use, for now it's mostly gonna be analog FM in 12.5 kilohertz of bandwidth. M17 call sign, okay, M17 we don't use it for now, and FM settings info, what is it? I'm gonna check that later. And then updated UI. Let's quickly have a look. Okay. Okay, lots of code. Alright. Alright. Good night, Wojciech. Okay, let's merge this branch in my branch. And great, no merge conflicts. I like that. And push so that it's online. Let's quickly clean and compile just to be sure that we don't have any new problem. Oh, 93 warnings. That's a lot. Ah. Oh. That's one weird error. Okay, this is not useful. So Jay, I don't know if you're listening, but basically you don't need to end it with this value because you are already trimming it to 16 bits. So this will be optimized away by the compiler anyway. What may be the issue is maybe it's lacking parentheses. So let's see if it fixes it. No, it doesn't. Okay, let's see what this FM settings is. Oh, okay. Okay, so that's used for the CTs, for the CTCSS. Okay. Well, let's ignore this issue for now, maybe. Okay, it seems to be the only one issue. I'm not really sure why it's complaining. Oh! Oh! Ah! Ah! Okay, I think I know how to fix it. So this can be just done like this. So this should be enough to fix it, I guess. Okay, but the way you were doing it was a bit confusing because this settings, it's done inside, it's inside the structure, so it's taking 2 bytes inside the structure, and you can just convert it to a 16 bits integer. And that's it, you don't need to dereference it and things like that. So let's see if it's still complaining or not. Ah! Oops! Maybe I was not that right after all. What if I do this? Is it complaining? Okay, so this is valid. Yeah, we basically can just do like this. It's the same type, so we can just do a simple assignment in comparison, I guess. Did you try this already, Jae? Ah, it doesn't know. Does it complain if I do this? Oh, that's very strange. Okay, if you tell me that it's not interfering, just those we don't need, so okay, let's keep it like this. Radio settings, get, okay. The name of the song is this. Okay, getting back to the task radio, transceiver configuration, then let's include radio settings of H. What's the data type already? Forgot. Radio settings T, okay. Radio settings get settings. Yes, rather than a strictest. But maybe it's because of the alignment, but maybe we don't really need to declare that one packed. So when it's in the code like this, it being packed is not like critical. It would be an issue if we were to store it in the NOR flash, for example, like as is. As a whole data type, then we would be storing useless data in a precious memory which we can't erase that often. That would, to me, be an issue. But in this case, we will probably be saving, I don't know if that's what you do, saving all the fields one by one in the EEPROM, reading them one by one, and so if we don't declare the struct as packed, we are gonna lose a few bytes of memory in the code, in the RAM, but we will also have our accesses a bit faster and maybe comparisons a bit faster. So it's, as always, when you are coding, it's a trade-off that you have to do between using memory and being fast. In this case, I would not use packed and just leave it be, and because yeah, making it packed might have weird issues in the cases in which we are. So anyway, we are getting the settings, and so Oh, forgot about something. Yes, not a big problem, but I will explain. So when I initialize the transceiver, I tell it to ignore everything from the LVDS pairs, which is right. However, we haven't enabled the IQ interface yet, so actually not a big issue. However, I can enable a few things right here. So maybe let's do that and have a look at what Wojciech wrote for his demos in Sept. No, where would it be? Config command. Oh yeah, basically 000B, and let's have a look at what this is. This is this one. And we write to it this. And that would be one shifted by 4 places, so this. And one shifted by 2 places, so skew. Yeah, I think this is a default skew. Yeah, indeed. So actually I can maybe just set it here. Oops. So this way we set the IQ pairs to failsafe, but we also enable them. I haven't looked at OpenRTX and the way they do things. So you can have values in a uint32 without having to declare your value packed, your structure packed. When you are gonna declare your structure packed, it's gonna force it to be aligned on a certain number of words, of bytes, and I think we might be... So if you have 4 byte values following each other, and then a 32 bits, 4 bytes one, so 4 bytes and a uint32, then it won't change anything if you declare it as packed or not. But if you have like 1 byte, 1 word, and 3 bytes, then the word is gonna be aligned on a 4 bytes barrier. So you are gonna have 1 byte, 3 empty bytes, 1 word of 4 bytes, and then 3 bytes, and then 1 more byte, which is reserved. Look at the CPS file. Where is it? Yes, FM info. I'm pretty sure. Yeah, okay, maybe if we didn't set that one as packed, it would be saved as a 32 bits integer. I don't know. I don't think so, though. I don't think the packed attribute will change anything on this one. I'm not sure. I don't think so. On this one either. Yes, you're right, you should use it as a uint16 in the NOR flash. That's how you should do it. So this one, for example, declaring it as packed might change something, because we have 16 bits values and 1 8 bits at the beginning. So maybe it would, I'm not sure though. Sometimes it also depends on your compiler and things like that. Here it's gonna change because we have 888, 32, 32. So if we declare those first, it may be better. Oh, and this one is, yeah, okay. Anyway, let's not worry too much about that right now. We start the IQ interface and declare it as failsafe because it's not driven by the FPGA yet. And so that's the only configuration that's done. Then we configure the FPGA. Well, actually we don't need to set that right now. Actually, we don't even need to set anything right now. Then we configure the FPGA, it starts, we read, blah blah blah, we read the version number and so on. Here, we will configure the IQ interface, but now the FPGA has started and so on, so the IQ interface is driven, so we don't need to worry about setting it in failsafe mode or anything like that. So that's good. That's the configuration command. It should always be done whenever the transceiver is started. Okay, so then we have to use the settings. And what should we use? AGC target, FM settings, blah blah blah. Modes. So case. Yeah, no worries. For now, I think I will just reuse the one you had because that's the only one I need for the first real transmission. So case, case FM. Okay, so whenever we are in FM mode, I think this is my settings now. Okay, I will take care of them. I would have to tell the FPGA to be in the correct mode. That I don't really know how to do it yet, even though I could have a look. So configure FPGA, and then we are gonna do okay. not sure how I should decide how I read or write a register from the FPGA. My guess would be that Wojciech made it kind of the same way the transceiver does it. So I'm not sure though, so I will ask later on. So let me just do very quickly 2 additional functions. (32) and basically we are gonna do the same as we do here, except that we select the FPGA chip. And we don't need that many buffers. No, for read we do need. So we need 4 bytes buffer. Addresses, okay, except that for the addresses, I believe those are stored in, given that the system is in Little Endian, I can't do exactly the same as I did here. Or I do have to, well, even though 00, maybe I will do this. So invert the 2 different bits to do the 2 bytes in the definition of the register, so that it's just easier to handle for me. I prefer to do it this way. Okay, I think we are near the end. Yeah, okay, we are done. Sorry for this. Okay, so when we read the register, hey, wait a minute. I'm missing something here. So to write, I have to set the highest bit. So that's how you, no, not to read. Right, I said. So right here, I have to set the top bit, or ensure it's set. Maybe it's already set. I don't really care about that in this function. Just ensure that it's set, and so that means that whenever I will be interacting with this register, I'm gonna write in it. Okay, I don't know if it is what Wojciech did, I'm not sure, so and I just won't do it now. Well, let's keep it, copy it, so. Okay. Okay, so same here, 4 bits. That for that I fear that we will have to move bytes around like this. Okay, just tell the transfer is 4 bits instead of 4 bytes, sorry, instead of 3. Wait SPI transfer done, wait SPI transfer done. That's all good. Okay. Don't think we need that one. Just this is enough to make us wait. Data, okay, we need to set that, so that would be the topmost bit, so convert it to a 16. Oh, sorry, misclicked. Convert it to a 16 bits word, move it by 8, plus buffer RX last byte. So that way we have functions to read and write. Let's just declare them at the top of the file. Right here, we'll do it. Okay, great. Wait. That's how it should be. Read, we take the pointer, write, we take the value. Okay, checking that everything seems alright. It does. Hi, good evening, Pierre. Oh, strange, I didn't see your message on the M17 Live Discord channel. I don't know why it's not appearing. Anyway, good evening, Pierre. So back to the FPGA configuration, transceiver configuration, sorry, basically radio configuration, because we have to write configuration to both FPGA and transceiver. So then we will do write register in register CR1. And we are gonna write, oh, I'm not sure what what everything means here. Also, okay, let's just check a few sanity, add a few sanity checks. Okay, just declaring very quickly a flag for the bands that we are gonna use, because we do, for now, we decided for loads of reasons, and because it's easier to do like this. For now, this version of the radio won't allow cross-band operation. We have only one SMA plug. That means that we, most of the time, will only have one antenna attached, and so I don't think there are antennas for 2.4 gigahertz and 430, or maybe if you have those, it's not very common at the very least. let's use the same terminology. Okay. Just so if we are in crossband operation, which is what this check is, so if TX band and RX band are not the same, then we tell the user that crossband operation is not supported and we get out of here. Then we are sure that those have the same value. And so yes, making a diplexer would be possible, but on this board we only have a switch that we configure manually for 2.4 or sub-gigahertz. So also we should okay, I don't remember. Okay. Documents, datasheet. All right. How do we have to set those pins? Okay. When both are low, it's shut down. Great. RF1, which is RF1 is sub-gigahertz. Just making sure that RF1 is indeed pin 4. RF1 is pin 4. Great. So if we are in sub-gigahertz, bye Steve! I won't be much longer, it's already quite late and I've been streaming for 2 hours now, so I won't be much longer. Just trying to write a few quick and easy functions and then we will be good. So sub-gigahertz. Right pin. So sub-gigahertz we want to set, so RF1 we want to set them both high, I guess? Yeah, RF1 high. like this, and if we are in this band, we want to set 1 high and 2 low. 1 high and 2 low. Okay. Then we configure the FPGA for, I don't know what we are gonna. I guess we are gonna want to set CR1 to mods FM and IO0 data ready. I guess we will want to set demodulation in FM2 and band 209. Oh no, let's try a few quick things. So that would be if we want to if we are in band sub gigahertz, we have 0, so it would be so that way we don't even have to branch in the code. What do we have to write? Yes, so I guess FPGA write register CR2, and here we will have to write naming is quite confusing. I guess it's channel receive. Oh yeah, that's the channel width for the receive filter. So we will want to set it to THRX 12.5 with FMTX hey, am I in narrow or wide? I guess we are in, I think we are in wide, I'm not sure. Because we have more operational modes, so we have FM, FM narrow, FM wide, and here we only have FM narrow and wide. So that's CTCSSTX. Oh yeah, okay. Old yeah, maybe redundant. We will have to clear that out later on. That's no problem for now. Yeah, creating contents to have a nice GUI, I get the feeling. No issues here. So that's also we will have to decide on which tone we use, which I think settings that FM settings dot TX tone. CSS is stored as an index in the tone array. Okay, great. Settings FM settings dot oh, I can't use a ternary operator. No, I can. Okay. Well, I guess I don't really need that. Do I? Okay. Stereo FM mode. Well, we have in the hardware, we have everything we need. No, actually we don't, because we can't tune the transceiver to below 389 megahertz, so we are not able to listen to broadcast FM. But if you use a mixer, an up converter to increase the frequency of the FM broadcast band, you would be able to have decoding options. You would need to add them because we haven't added them already, but you would be able to. So we set the RX filter to 12.5, TX in wide, CT/CSS we set it, unknown would be 0, so that's what is done here. Then state idle TX on RX, we are gonna set it to RX. Okay, the offsets, I don't know what we have to do in here. I don't think we... Sorry, I don't think we have to change anything right here. RSSI and so on. Okay. So with this, we should be all set. And then next step is, I guess it will be for tomorrow, because we have to re-implement the set frequency. and I would like to have a look into this before I just copy it, so that at least I understand what I write. And this, oh yeah, it manages the RX and TX, but we are gonna manage it in another way. Okay, I think that's quite a lot for today, given the time of the day and how tired I am. So let me just shut down the scope, unplug this. Okay, so I think that's gonna be it for today. Yeah, it's been a good day, especially for those who received their OpenHTs, I guess. So for those who haven't followed the OpenHT Discord channel, which is very, very active those days, both Wojciech and Jae received their OpenHTs because they are helping, of course, a lot with the development. So Jae has been doing the case that we should have to display on, at Friedrichshafen. So if you are at Friedrichshafen, you will be able to see the case that Jae designed, which, given what I have seen, is very promising, very, very interesting. Definitely will avoid me breaking the board. So for those who also didn't follow the story yesterday evening, we have a first casualty. So we already damaged the board last stream. I kind of smashed it in the desk, but I was able to fix it. But now the FPGA was, it seems that the FPGA is completely dead. So first casualty, maybe an ESD discharge, maybe, I don't know what happened, but FPGA is dead. Shit happens, you know. So first casualty, I'm now on my second board. I have a third which is prepared in case I have an issue, so I minimize downtime. Yeah, experiment called for accidents, exactly. So, but I'm using the boards without any protection because, you know, I'm probing, moving here and there and touching everything, and I don't have an anti-static wrist wrap all the time because it's very unpractical, even though I should try. So yeah, first casualty, shit happens. We have several of them. But yeah, still have loads of them. Wojciech also have his boards now to be able to debug and use and do the FPGA code more efficiently, which is great too. We really need him to go as fast as possible, and especially using the hardware that is in the OpenHT proof of concept, because for now he has been using the FPGA development board, which, even though it's good, it's not the hardware that we use, so it's not exactly the same thing, you know. Anyway, that's it for today. Thank you everybody for following along. I hope you enjoyed, I hope you found it interesting, maybe you learned a few things, who knows. It was fun doing this tonight. We had no major problem, we did some progress, and that was nice. So 73 to all of you, thank you, hope you enjoyed, don't forget the Discord, and see you on the next stream, maybe tomorrow, I don't know for sure yet, but I will keep you informed on the Discord channel as usual.